So this is lesson 3.3, solving systems of inequalities by graphing. We're going to be revisiting graphing inequalities again, this time with systems of equations. For our example, we've got the system of inequalities 4x minus 3y is less than 12, and 2y minus x is less than or equal to negative 6. First thing we want to do is start off by solving both of these equations to get them into slope-intercept form. So starting with my first equation, I'm just going to subtract 4x to both sides so that I can have the y by itself. And the next thing that I'll do is divide both sides by negative 3. And as you may remember from back in chapter 2, anytime you divide an equation, divide an inequality by a negative value, so in this case negative 3, you need to flip that inequality sign. So now we have y is greater than 4/3 x minus 4. For my second inequality, I'm going to also isolate the y variable, this time by adding x to both sides. And next I'll divide everything by 2. So then I have the equation y is less than or equal to 1/2 x minus 3. So here are the two inequalities that I'm going to be graphing on the same coordinate plane. So for my first inequality, I am going to start with my y-intercept at negative 4, and then I'll be moving up 4 and to the right 3. Now, for connecting my points together, this is the greater than inequality, which means that when I connect the points on my graph, I want to be sure to use the dashed line. So there's my inequality. Now something else you might remember from when we did inequalities is we also need to find the solution region. Since we have this dashed line here, we want to determine if the solutions to our inequality are going to be over here on the upper portion of my graph or below on the bottom portion. So in order to do that, we need to test a point that is not on our line. So I'm going to test the point 0, 0, since 0, 0 is not on this blue the blue line that I have just drawn. So going back to the original inequality, I'm going to plug 0 in for both my x and my y value. When I do that, when I make that substitution, I end up with an inequality statement that says 0 is less than 12, and this is a true statement. 0 is less than 12. So because I have a true statement, let me get my highlighter. Because I have a true statement that 0 is less than 12, I want to shade in the side of my line that contains the ordered pair 0, 0. Because it was true. So that's going to be everything on this upper portion of my blue dashed line. I am coloring in yellow since I had a true statement. So next I'm going to go ahead and graph my second inequality, which was y is less than or equal to 1/2 x minus 3. So I'll be starting this graph at negative 3 as my y-intercept. For my slope, I'm going to move up 1 and to the right 2. I'm also going to go down 1 and to the left 2 just to get some extra points on here. This line I'm going to connect all of my points together with a solid line, since I have the less than or equal to inequality symbol. Now looking at my blue solid line, I also need to shade for the solution region for my equation 1/2 x minus 3. So looking at my second equation, I am substituting in 0 again for the x and the y variable, since the ordered pair 0, 0 right here is not on my solid line that I just drew. So if I substitute 0 in for both x and for y, I now end up with an inequality statement that says 0 is less than or equal to -6. This statement is false. So I'm going to pick another color, and I am just focusing on my solid blue line. So looking at the solid blue line right here, the ordered pair 0, 0 is above my solid line. And because this was a false statement, I am going to shade below my solid line. Now I picked the blue highlighter. So you should notice that where my blue and my yellow overlap, it's turning green. With systems of equations, when we graph, we know that we are to be looking for the solution where the two lines intersect. However, with inequalities, since we have such a large solution region which we're shading, we're actually looking for a feasible solution region where where all of the solution regions are intersecting. And so in this case, the green section of my graph that you see here, that's my feasible solution region. That means that any point that falls right here on this line, because it's solid, or within this green area, is going to be the solution to my system of inequalities. Thanks for watching.